Welcome to the deep dive. We are tearing apart the source material you shared with us to give you a shortcut to being truly well-informed. Today, we're diving into the humble, often misunderstood daytime nap. For a long time, napping was categorized as either, pure European luxury or simple American laziness.
Yeah.
But the scientific literature we've analyzed tells a much more nuanced story. The nap is a highly sophisticated, regulated physiological event.
It absolutely is. And our mission today is to give you that comprehensive view. We're synthesizing research across neuroscience, cognitive studies, including some great work from UC Berkeley and Johns Hopkins, and recent sleep medicine reviews published in places like the NIH database. We want to understand the nap paradox, why a short, perfectly timed nap can be a powerful cognitive boost, but why frequent long napping might be a critical signal of underlying health issues.
Right, because the sources show us that the nap isn't just about reducing your immediate sense of tiredness. It's about optimizing your brain's architecture for future learning and even creative insight. It's a fundamental performance enhancer. Okay, so let's unpack this by looking at the brain's internal housekeeping. Why, physiologically, does a short sleep in the middle of the day help us remember things we encountered hours earlier?
Well, we need to start with the concept of memory storage. Think of the brain's hippocampus as your temporary, limited capacity workspace.
Like an email inbox.
Exactly, like an email inbox that gets full really quickly with new facts and events. So to prevent that memory overload, that fact-based data, what we call declarative memories, it has to be securely moved or consolidated into the brain's much larger permanent hard drive.
The prefrontal cortex.
That's the one.
So if I take a brief nap, I'm essentially hitting send on the day's learning, clearing space for the afternoon.
That's a good analogy, but we have to be careful not to oversimplify it. The sleep process itself is what drives that transfer. If you don't clear out those fact emails, new information you encounter in the afternoon is going to be stored less efficiently or might even bounce entirely.
And this whole system is regulated by two different processes, right?
Yes, two dual processes. First, you have process S, which is the homeostatic sleep drive.
That's just the raw pressure to sleep.
Right. It builds up pretty much linearly the longer you've been awake. The accumulation is linked to the buildup of adenosine.
A byproduct of our cells just using energy.
Exactly. So the longer you're up, the more adenosine you have, and the higher that pressure gets. A nap directly and, very efficiently reduces that adenosine load. It lowers the pressure.
But if it were only about process S, we'd just crash hardest at 10 p.m. Yet almost everyone recognizes that classic mid-afternoon wall, that energy dip between 1 and 4 p.m.
And that's where process C comes in, the circadian rhythm.
The body clock.
Your 24-hour internal biological clock. It's governed by the suprachiasmatic nucleus, the SCN, which is this tiny pinhead-sized master clock deep in the brain. The SCN generates a powerful, continuous alerting signal that typically counteracts the rising sleep pressure of process S, keeping you functional.
It's like having a co-pilot whose only job is to just keep the engine revving high.
Precisely. But that alerting signal naturally and inevitably experiences a powerful lull or dip in the mid-afternoon. That's the infamous post-lunch dip. When you combine that natural reduction in the alertness signal from the SCN with the sleep pressure that's been building all morning, well, that's the physiological sweet spot for napping.
And once you decide to fall asleep, the brain doesn't like being in some kind of wishy-washy half-sleep state, does it?
No, it seeks stability. The transition between full wakefulness and full sleep is managed by a rapid, all-or-nothing system, what neuroscientists call a flip-flop switch.
A flip-flop switch. So it's either on or off.
Pretty much. Wake-promoting neurons and sleep-promoting neurons, like those in the VLPO, they mutually inhibit each other. When one side wins, it rapidly shuts down the other, allowing for those fast, stable transitions we need.
So that sophisticated switch ensures your brief rest is actually restorative.
It does.
Okay, that structural integrity means even a short rest is meaningful. So let's move past just feeling rested. What specific cognitive benefits, what superpowers can a nap unlock?
Right. When we talk about superpowers, we have to look closely at the architecture of the nap itself. We're not just promoting consolidation, we're enhancing subsequent learning and memory. And the type of benefit you get is entirely dependent on the specific sleep stages you manage to hit.
So it really matters whether I just lightly drift off or if I fall into a really heavy sleep.
Absolutely. If you hit slow wave sleep, or SWS, sometimes called N3, that is critical for strengthening declarative memory.
The facts and events we were talking about.
Yes. Consolidation happens here because during SWS, neurotransmitters like acetylcholine, their levels drop way down, which allows the neurons that fired while you were learning to reactivate and solidify those memory traces into the neocortex. It makes them permanent.
Okay, so SWS is for facts. But where does the creativity come from? I think this is where it gets really interesting for anyone who solves complex problems for a living. What about those random aha moments when a solution just suddenly crystallizes?
That is linked to the lighter stage, N2 sleep, which is generally the longest stage of a typical 90-minute cycle. And while N2 is known for consolidating motor skills, recent research has found it's massively important for insight. A landmark study showed that an astounding 85.7% of participants who achieved N2 sleep in a brief nap gained insight into a hidden task strategy,
Wow. Compared to what?
compared to only 55.5% of those who just stayed awake.
That is a staggering performance jump. A simple 20-minute nap gives you a near certainty of a creative breakthrough. What is N2 doing structurally to make that happen?
The mechanism is tied to the concept of synaptic downscaling, sometimes called the synaptic homeostasis hypothesis.
Okay.
Think of your brain's connections like a complex flow chart or an overly cluttered desktop with hundreds of apps open. If every connection is equally strong, the signal-to-noise ratio is terrible. While you're in N2 sleep, the brain is actively pruning or downscaling weaker neuronal connections.
You're essentially debugging your own cognitive program.
Exactly. It creates a clean slate, allowing you to discover optimal, simpler strategies that were previously hidden by all that noisy clutter of overconnectivity.
You can actually see this.
You can. This neural pruning process is reflected physically. It correlates with a measurable, steeper EEG spectral slope during the nap, which researchers found was the strongest predictor of achieving those insight moments.
It's physically optimizing the neural network while you're briefly offline.
Amazing.
So beyond facts and breakthroughs, does the nap affect our ability to handle, say, the emotional load of the day?
Yes, studies confirm the benefit for emotion processing. Research, particularly with preschool children, demonstrated that naps significantly reduced something called emotional attention bias. And the nap also preserved the emotional valence of negative stimuli, which suggests that sleep temporarily disrupts the wake-dependent process of emotional habituation.
So it keeps emotional fatigue from just piling up all day. It helps you reset.
It helps you reset your emotional landscape, yes.
Okay, so we've established the nap as a massive cognitive tool. But now we have to turn to the central paradox, the part that sounds really counterintuitive. If naps are this powerful, why are frequent, long, or seemingly required naps associated with poor long-term health outcomes, especially for older adults?
This is the core of the nap paradox, and it demands a really careful look. The studies have shown a robust correlation, mostly in older populations, between habitual or frequent daytime napping, what's often called essential napping, and an increased risk for serious conditions.
Like what?
Hypertension, diabetes, functional limitations, mortality, and cognitive decline.
That shifts the entire risk assessment. So is the nap itself actively detrimental, or is the napping behavior a symptom of something deeper that's already going wrong?
And what's fascinating here is that most researchers lean heavily toward the latter.
Ah,
They suspect the nap is not the cause, but a critical diagnostic marker. And there are three main hypotheses exploring this.
let's start with the connection to cognitive decline. Is the sleep causing the decline, or is it the other way around?
That's the symptom hypothesis. The theory suggests that age-related deterioration in brain integrity is the real driver here. For example, the deposition of neurofibrillary tangles in critical brainstem areas can alter the cholinergic activity you need to maintain stable wakefulness.
Okay.
This degradation leads to pathologically increased daytime sleepiness, which then forces the individual to nap more frequently.
So the nap is merely a behavioral response to an undetected accelerating neurodegenerative disease.
Exactly. The nap is just the symptom of an underlying engine failure, not the cause of it.
Okay, so what about the direct physical risks, like increased mortality?
That's covered by the causality hypothesis. Researchers link frequent napping to cardiovascular risk through the sympathetic nervous system.
The fight or flight response.
Right. If a person is forced to nap multiple times a day, they are having frequent bouts of waking up. That transition from sleep to wakefulness reactivates the sympathetic nervous system. These multiple daily surges lead to temporary but significant spikes in heart rate and blood pressure. And the hypothesis suggests these repeated jolts could cumulatively increase the risk of adverse cardiovascular events over years.
That's a real danger hidden inside what looks like an innocent habit, the sudden jolt of waking up just multiplied daily.
And then there's a third, very compelling and emerging theory, the inflammation hypothesis.
Okay.
This one ties both of those risks together. Chronic, low-grade systemic inflammation, often caused by age, obesity, or some other underlying disease, is powerfully linked to elevated daytime sleepiness. The hypothesis posits that the body may be inducing napping as a biological attempt to normalize those inflammatory markers.
So napping isn't the villain here. It's an internal mediator that's trying, and maybe failing, to fix an internal inflammatory crisis. It's a marker of a pre-existing burden.
And that's the key takeaway for you, the learner. For healthy young adults, napping is a power tool. But for older adults, frequent required napping should immediately prompt a deeper investigation into underlying diseases.
Okay, let's make this actionable. For those of us who are healthy and want to optimize our performance, what are the specific evidence-based rules for crafting the perfect power nap?
Duration is non-negotiable. You have to aim for a short power nap of exactly 10 to 20 minutes.
Why so strict on the duration? What happens if I drift a little longer?
That 10 to 20 minute window ensures you stay predominantly in the lighter N1 and that insight-generating N2 sleep stage. If your nap exceeds 30 minutes, you significantly risk dropping into that deep SWS or N3 sleep. And waking abruptly from N3 induces sleep inertia.
Ah, the grogginess.
Severe grogginess, disorientation, and reduced performance that can last for an hour or more. It makes you feel far worse than if you hadn't napped at all.
And timing. When should we schedule this window to hit that natural dip?
You want to target the natural dip governed by the SCN, which for most people is generally between 1 p.m. and 4 p.m. And timing is also vital because napping too late, say after 5 p.m., will start to steal your sleep pressure, reducing the quality and duration of your crucial nocturnal sleep.
A daytime nap should enhance, not replace, nighttime rest.
Exactly.
I love learning about strategies that maximize benefits by combining systems, and the coffee nap is peak optimization. How does this technique perfectly align the chemical and biological processes?
The coffee nap is brilliant because it leverages the science of adenosine and caffeine absorption. The strategy is simple. Consume about 100 to 200 milligrams of caffeine, so a standard cup of coffee, and immediately lie down for a 20-minute nap.
Why immediately?
Because caffeine takes approximately 20 minutes to be fully absorbed and peak in your bloodstream. So while you're napping, your brain's natural processes are clearing out that fatigue-inducing adenosine. That's the main job of the nap. Then, when the alarm goes off and you wake up, the caffeine is just peaking. It then binds to the now vacant adenosine receptors, immediately blocking any new adenosine from binding.
So you get the double benefit. The nap physically clears the neural clutter, and the caffeine immediately locks down the receptors, giving you this huge, clean jolt of energy. Studies show this combination drastically enhances performance compared to either just caffeine or just a nap alone.
It is the ultimate hack. And finally, if you struggle to transition into that restorative N2 sleep in such a short window, research suggests you can improve your depth of rest. Studies, including some with military personnel in really challenging settings, found that using simple relaxation techniques like progressive muscle relaxation or elements of self-hypnosis significantly increased total sleep time in the nap, primarily by boosting that beneficial N2 stage.
So what does this all mean for you, the learner? The main takeaway is that the nap is not a guilty pleasure. It is a powerful, highly specific cognitive tool. You get memory consolidation from SWS, and you get pure, creative problem-solving insight from N2 sleep. But duration and timing are everything to avoid that dreaded sleep inertia and nocturnal interference.
And we must emphasize the importance of context. For a healthy individual, a short, intentional nap is clearly a performance boost. But in older populations, the habitual, required urge to nap should be viewed differently. It is a critical diagnostic marker. Don't treat the symptom by just fighting the nap. Look for the underlying disease process, whether it's cardiovascular or inflammatory.
This raises an important question that sleep science is still intensely pursuing. If frequent required napping in older populations seems to be correlated with inflammatory disease and mortality, is it possible that for those individuals, the nap is not merely a coping mechanism for tiredness, but an evolutionary-driven yet ultimately insufficient biological attempt by the body to self-medicate against low-level systemic damage or chronic inflammation? Maybe that 20 minutes is the body initiating an internal repair job that really requires a full 8 hours to complete.
It suggests the body knows it's damaged and is